Hello everyone, welcome to Agile Rank Mate. Today we'll be discussing the previous year questions of the talent examination TALLENTEX. Today we'll be discussing the previous year questions for grade 10. Let's begin then, shall we? First question from mental ability. 3 positions of the same dice are given below. Observe the figures carefully and tell which number will come in place of the question mark. We have options 1, 6, 3 and 5. Now to understand this, we have to understand the configuration, which of these numbers are opposite and how they are placed on the dice. Now if we look at the first and the second images, we can see that they have the number 3 in common. So let us change the configuration of either one of those so that it would make 3 in the same position. So let's make 3 at the top. Since in 2, 3 is already at the top, we do not need to change it. We have 3, 5 and 4. For the first one, if we are to change it, we will put 3 at the top. Now if we turn our head, we can see that 1 would be on the left side and 6 would be on the right side. This is just the first configuration but in a different way. Now from this we can get two things. We can get that 1 is opposite to 5 and 6 is opposite to 4. Since both of these are the same dice, this is just like rotating this dice to get to the other side. So we'll get 5 will be opposite to 1 and 6 will be opposite to 4. Now the remaining number is 2 and 3. So from that we can also say that 2 is opposite to 3. Now let us consider 2, that is the configurations 2 and 3. In this we see that the number 4 is common in both of these. So let us change the position of both of these such that 4 is on the top. In the third one, 4 is already in the top. So with that we can write 4, 2, question mark. In the second one, if we do this, if we change 4 on the top, we will get 3 on the left side and 5 on the right. This is the same thing but in a different position. So from this, we get 3 is opposite to 2 as we have already discussed. However, the important thing over here is 5. We get 5 is opposite to the question mark. Now, since this is the same dice, we already know that 1 is opposite to 5. So 5 is opposite to question mark. So from both of these, we get question mark would be equal to 1. So in this question, we have to find which number will come in place of the question mark. And we got number 1. So option 1, 1 is the correct answer for this question. Next, we'll be doing a question from physics. A ball having initial velocity v is dropped from a height of 10 meters. It loses 50% of its energy on striking the ground and rises to the same height after collision. The value of v is, we'll take g equal to 9.8 meter per second square. 1, 7 meter per second, 2, 14 meter per second, 3, 35 meter per second, and 4, this event seems impossible. Now, let us consider the situation through a diagram. So let's say the ball is placed, not placed, that is, it is thrown from a height h, say, let's take it as h, even though we know the height as 10 meter. In order to ease our calculations, we will form a formula, and from there we will simplify the formula, and then we will replace the values of h and g respectively. Now, to find the total energy of the ball over there, we can say that total energy of ball at h, that is in this position right here, would be equal to the kinetic energy due to this velocity v. Let's write it down. This would be equal to kinetic energy due to v plus the gravitational potential energy. which is caused due to a height h from the Earth. So the kinetic energy due to V, we know that the formula of kinetic energy is half mv squared plus, and the gravitational potential energy would be equal to mgh. So this is the total energy of the ball at h. Now let's move on to the next scenario where the ball is in the ground or touches the ground. During this collision, 50% of the energy is lost. So on striking the ground, 50% of total energy is lost. And then the question is also says that after striking the ground, it rises to the same height after collision. So it rises back to height h. Now, what would be the energy at height h? It will only have potential energy of mgh. So since energy is constant, that means when it was first rising after collision, this would also be equal to mgh. 50%. So from that we get that mgh is equal to, and before that we need to know that 50% of what is equal to mgh. Now we know that the energy at h previously was half mv squared plus mgh. So the energy after falling down would also be equal to that. But mgh would be equal to half of the total energy at h, the total initial energy at h. So from this we get half mgh is equal to half into half mv squared plus mgh. Now if we simplify this, we have m common, and half into half v squared equal to 1 by 4 v squared plus half into mg is equal to half mg. Sorry, half gh. We would be left with gh since we took m as common. So half into g into h and mgh. From this we can cancel m and m. We get gh is equal to 1 by 4 v squared plus half into gh. Now if we take plus gh to the other side, we get 1 gh minus half gh, which will get half gh in the end, is equal to 1 by 4 v squared. From this you can cancel the denominators 2 and 4, and over here will become 2. And if we take half to the other side, we get v square. That is, if we change the sides, we get v square is equal to 2gh. So what do we have to find? We have to find the value of v. So v would be equal to the square root of 2gh. Now we will replace the values. G is 9.8 and the height is 10 meters. So this will be equal to root of 2 into 9.8 into 10, which is equal to root of 2 into 98, which is root of 196. Now we know that root of 196 is 14. So from this we get that v is equal to 14 meter per second. Now if you look at the options, we can see option number 2, 14 meter per second, is the correct answer for this question. Other options are incorrect, and the fourth one is also incorrect. So we had to understand the question and relate the values given and form a formula, and with that we'll simplify it, and then we'll replace the values and we will get the answer for the initial velocity, which is equal to 14 meter per second. Now let's go to the next question on chemistry. Acetic acid was added to a solid X kept in a test tube. A colorless and odorless gas Y was evolved. The gas was passed through lime water, which turned milky. It was concluded that, and we have 4 options, with these the conclusions. And so let us look at the question. Now we see that a colorless and odorless gas Y was evolved, and this gas, when passed through lime water, turned it milky. So this means We know that the gas which makes lime water milky is carbon dioxide. So we get that Y is carbon dioxide. If we look at the options, we can see that option 4 says Y is SO2, which is incorrect. So option 4, we can eliminate option 4. Now in all the other options, we have CO2. Now let us look at each of the options. The first option, we have sodium hydroxide. So if we look at the equation for sodium hydroxide, NaOH plus acetic acid, which is CH3COOH, this would give sodium acetate, that is CH3COONA plus H2O. This would be a displacement reaction where Na replaces H from its solution and forms CH3COONA plus H2O. Now here we need to note that in acetic acid, this is the cation and this would be the anion. So Na would replace H and not CH or any other substances. So, but over here we can see that there is no carbon dioxide being evolved. So option 1 is incorrect. Now let's look at option 3, where it says solid X is sodium acetate. Sodium acetate's formula is CH3COONA and it is mixed or reacted with acetic acid, which is CH3COOH. Now this, we will get no reaction, as even if it displaces, we'll get the same solutions again. So this would get no reaction. This means that CO2 would not be formed in this reaction or in this apparatus. So option 3 is also incorrect. From elimination, we can see that option 2 is correct. However, let us look at the option. Solid X is sodium carbonate. So if we react sodium carbonate, that is Na2CO3 plus CH3COOH. Now this is a classic reaction of an acid reacting with a carbonate compound. So from this, we'll get the salt CH3COONA, that is sodium acetate, plus CO2 plus H2O, which is there in the normal reaction of an acid with a carbonate. So here we can see that the colorless, odorless gas CO2 is evolved, which turns lime water milky. So from this we can confirm that option 2 is the correct option, where solid X is sodium carbonate and the gas Y is carbon dioxide. Note that solid X could also have been sodium bicarbonate or sodium hydrogen carbonate. That is, in the case of number 4, it is given. However, in that option, the gas Y is given as SO2, which is incorrect. Therefore, option 2 is the correct answer for this question. Now let's move on to the next question, which is on biology. 2 arteries and 2 veins are labeled in the diagram given below. Which of the following are arteries? So in this, we have to understand the concept of arteries in order to answer this question. We need to understand that arteries are not the same as the vessels carrying oxygenated blood. Generally, arteries are the ones which carries oxygenated blood, but not always. So if we talk about the vessels carrying oxygenated blood, we know that the left side of the heart, that is over here, this would be the left side of the heart, since it is in our view, and this would be, that is, D and B would be the vessels carrying oxygenated blood. So D and B. However, we are not talking about vessels carrying oxygenated blood. We have to find out which of the following are arteries. Now, arteries are the ones, the vessels, which carries blood away from the heart, or that is, blood from the heart to other tissues and organs. So to the other organs. So from this we can say that blood is carried away from the heart. So if we look at the diagram, we can see that in the part B and in the part C, blood is being carried away from the heart. That is, B is the aorta and C is the pulmonary artery. So that means B and C are the arteries in the given diagram. So option 2, B and C is correct. Option 1 is incorrect because those are the vessels, B and D are the vessels which carry oxygenated blood. And in this case, we are talking about arteries. So first 1 is incorrect and 3 and 4 is incorrect because in option number 3, A is a vein, and in option number 4, D is also a vein. So option 2, B and C is the correct answer for this question. Now, let's look at the last question of this episode from mathematics. A rectangular tank has an inner length and breadth of 24 meter and 20 meter respectively. Water flows through an inlet pipe at 180 meter per minute. The cross-sectional area of the pipe is 0.5 meter square. The tank takes half an hour to get filled. Find the depth of the tank in meters. There are 4 options. Now, let's understand the question. We have a rectangular tank. Let us draw the rectangular tank with the inner length and breadth of 24 meter and 20 meter. Now let's just consider the inner length, and since there is no information about the outer area or the outer length, we do not need it. So let this equal to 24 and this equal to 20. Now we have to find the depth of the tank. So let the depth of the tank be h, or if you want to call it height or depth, both of them are same. So the depth of the tank in meters would be h meters. So then we have a pipe which in which water flows at 180 meters per minute. Let's draw the pipe, and we are also given that the cross-sectional area of the pipe is 0.5 meter square. So this area, this whole area, would be equal to 0.5 meter square. And we are also given the information that the tank takes half an hour to get filled. So we have to get height from this, from the information about the water flowing into the tank and also the volume of the tank. So let the depth, which we already assumed as h, equal to h, and from this we can say that the volume of water flowing from the pipe through the cross-sectional area would be equal to 180, that is the flow, that is 180 meter per minute, into 0.5 meter square. 0.5 meter square. So this would be equal to 90 meter cube per minute. So per minute, 90 meter cube of water is flowing from the pipe onto the rectangular tank. So we know that the time to fill the tank is half an hour, which is equal to 30 minutes. So the total volume of tank that gets filled is the total water which flows into the tank, that is 90 meter cube per minute, into the time which it takes to fill the tank, which is 30 minutes. You can see that minute and minute will cancel each other, and 90 into 30, we get 2,700 meter cube as the total volume of the tank. Now, we know that the tank is a cuboid, so this volume of tank would also be equal to 24 into 20 into h. That is, the volume of a cuboid is the product of all of its sides, that is the 3 of its sides together. So let this be 1 and this be 2. So from 1 and 2, 24 into 20 into h is equal to 2700. From this we can find h very easily, which is 2700 by 24 into 20. 0, 0 cancel. 2, 270, we get 135. We can cancel 3, 8, and over here we will get 45. So h will be equal to 45 by 8. Now if we divide it, 45, 8 into 5 is 40. So 5 and remainder would be 5 and 50. 50 is divisible by 8, so 8 into 6 is 48. So 6 remainder 2. 20 is divisible by 8. 8 into 2 is 16. So 6, 2. And we'll get remainder as 4 and 40. So 40 divided by 8 is exactly 5. So this is basically just cancelling out. We'll get 5 and then the remainder will be 5. And if we add a point, we'll get 50 and so on. So forth, we get 5.625 minutes as the amount of time it would take to fill the tank. Sorry, not minutes. This will be meters. 5.625 meters as the depth of the tank. So if you look at the options, we get option 3, 5.625 meters, which is already given in the question, to be the correct answer. The other options are incorrect, which if you got would mean that you had made a calculation error. So in this question, we had to equate the volume of the tank to the amount of water it takes to fill the tank. That is basically the volume of the tank. From equating both of those, we get an equation from which we found the value of h, which is equal to 5.65 meters. So option 3 is the correct answer for this question. And that is the end of this episode. We hope you found it interesting. For more of such interesting videos, please don't forget to subscribe to our channel, Agile Rank Mate. Until the next video, take care, stay safe, ta-ta for now.